Hey there, in this video we are going to dig more into linear functions and what slope and y-intercept mean and how we can calculate them from different given pieces of information. So as a reminder, a linear function can be written in the format y equals mx plus b. M is going to represent your slope and B is going to represent your y-intercept. So slope is a measure of how steep the line is. So if you think about a hill, and while a hill, you typically, when you draw a hill as a kid, for example, you probably draw something like this. If we just focus on this part of the hill or this part of the hill and think about it as a linear piece and not curved, that can help us to understand what slope is. So a positive slope is going to be going up from left to right, like this portion of my hill. A negative slope is going to be going down from left to right, like this portion of my hill. So you can see that with these two examples right here. Now, slope is considered the ratio of the rise, which is the change in the y value, to the run, which is the change in x. And we use the words rise and run because that's a little more common knowledge. If you think about rise, rise is going to be your up or your down. Now, we usually think rise is going up, but technically it can go down if it is negative. If the number is negative for the rise, then that is going to be going down. And it's a ratio of that rise to that run, which is the left to the right, going left or right, depending again if it's a positive or negative number. But it's a ratio, so it's usually written as a fraction with our rise on top and our run on the bottom, which we'll get into in a minute. Now, there are two special cases of types of slope. The first one is a slope of 0. So if we have a horizontal line, that is going to be a slope of 0. If you think about that again in the concept of a hill, if it does not rise, it doesn't go up or down, it is not a hill. It has no slope, it has no increase or decrease. It's not going up or down. And then finally, undefined slope. This is actually not a function. So that is not considered a linear function. It is a line. It is a straight line. It goes up and down. It's a vertical line, but it is not actually a function because every single point on this line actually has the same x value. And that same x value, whatever it may be, is mapped to a whole bunch of different y values. For example, -1, 0, 1, so on and so on. So what that tells us is while it's not a function, it is an answer to a type of slope. So undefined is the slope of any vertical line. So now let's talk about how we find slope from a graph. So we're going to pick 2 points on the graph, and you'll see in these examples that I have 2 points already picked for you. You can pick any 2 points you would like if it's not already given to you, but I would suggest that you do points that are on the corners of the grid lines of the coordinate plane. So for example, here I picked 2 points that are on the corners. If you wanted to, you could have picked, for example, this point is on the corner and this point. I could have picked those two. It does not matter, but you'll find that if you can get them closer together, it usually helps you in terms of what you have to simplify in the end. So pick 2 points. We have that done on number 1. Step 2, starting at one of the 2 points, doesn't matter which one, you're going to count the rise, which is your up or your down, and the run, which is your left or your right. So let's talk about rise and let's talk about run. So your rise, if I pick this point right here, let's say, our rise, we are going up in order to get to that other point. We're going to have to climb up 1. That is our rise. It is a positive 1 because we are going up. And then our run would be how many do we go left or right, in this case, right. And that's going to be right 2. And because it's right, it is positive. So again, up is positive and right is positive. If we went down, that would be negative and left would be negative. So our run on this one is 2. So our rise over our run is going to be 1 over 2. So 1/2 is our slope of this line. Now, if you had picked the other point, you could go for your rise, it would be going down 1, which would be a -1. And then our run would be backwards or left 2. which would be -2. So if we had -1 over -2, notice that would still come out to be positive because a negative divided by negative is a positive. So that would still come out to be 1/2. So I wanted to point out, even if you picked a different way to get there for your rise and your run, you are still going to get the same answer if you do it correctly. Same thing goes if I had picked this point and this point. I would just be doing a lot more counting. So rise 1, 2, 3, 4, and then run 1, 2, 3, 4, 5, 6, 7, 8. But 4 over 8 still simplifies to 1/2. So no matter which 2 points I pick on that line, they will simplify to the same fraction once you've simplified it, as long as you write your rise over your run correctly. So on number 2, technically you can follow the same steps, but you'll notice if it's a horizontal line like we talked about on the last page, 0 is going to be your slope. So here our slope is 0, but if you wanted to count your rise or your run, if you pick 2 points on that line, any 2 points, you'll notice we do not rise. So our rise is 0 because we don't go up or down to get to the other point. We just run 1, or if you had looked at it the opposite direction, -1. Either way, you would have 0 over 1 or 0 over -1 or 0 over whatever number between the points, whatever 2 points you pick. 0 over 1 is 0. So again, you can memorize that a horizontal line is always going to have a slope of 0, or you can calculate it using that same process of the rise over the run. So looking at 2 more examples of this. Number 3, I picked 2 points for you. So you can see this one, I spread them out a little bit more. But if you count your rise and your run, it does not matter, again, which point you start at. I'm going to start at this one this time and work my way up 2. So my rise is +2. But then I have to go left 2, which is going to be a negative because I'm going to the left. So that's -2. My rise is 2, my run is -2, and then we have to simplify that. 2 divided by 2 is 1, and 2 divided by -2, that means that is -1. So our slope on this one is -1. It would have saved us a little bit if we picked points closer together. So for example, if I picked this point and this point, I would go up 1 and left 1. So that would be 1 over -1, which still simplifies to -1. Any points you pick on this are going to simplify to -1 when you divide. And then on number 4, again, this is one that you can memorize, or you can technically set up your rise over your run. So if you think about any 2 points, and I didn't draw any on this one, but if I pick this point and this point, your rise, let's say I go from the bottom one up, is 1. Your run is 0. We don't go left or right at all. 1 divided by 0, remember you cannot divide by 0. So that means our slope is undefined, because when we divide by 0, we get undefined. And so that tells us anytime we have a vertical line, it will be undefined as our slope. We can also find slope from 2 given coordinate points or ordered pairs, even if we don't have a graph. So this is our slope formula. So y2 minus y1 over x2 minus x1. And that is basically just saying that if we have 2 ordered pairs, and one of them is called x1, y1, and the other one is called x2, y2. So just 2 ordered pairs. We use the 1s and the 2s to indicate they come from the first ordered pair or they come from the second ordered pair. But technically it doesn't matter which ordered pair has the 1s and which one has the 2s, as long as the 1s are together in the same ordered pair and the 2s are together in the same ordered pair. So looking at this example here, 0, 5, and 2, 15, if I call this x1, y1, and x2, y2, I can go ahead and use my formula for slope, and I can do y2 minus y1 over x2 minus x1 by taking the 15, y2, minus y1, which is 5, all over x2 minus x1, which is 2 minus 0. Now I do want to point something out. Because I started with the 15, y2 in this case, and I subtracted y1, I have to start with that same ordered pair when I go to the x's to subtract those. So 2, I'm going to subtract 0 from that. So you always have to start with the same ordered pair. So if I started with 15 minus 5, I couldn't have done 0 minus 2 on the bottom. It will not work out to be correct. Your signs will be incorrect and potentially your numbers as well. So 15 minus 5, 15 minus 5 is 10 over 2 minus 0, which is 2. And then we can go ahead and divide. 10 divided by 2 is 5. So our slope on this one is 5. On number 2, so again, I'm going to go ahead and call this x1 and y1 and x2 and y2, but technically you could have flip-flopped these and make these 2's and these 1's, and you're still going to come out with the same answer. You will just have slightly different work to get there. So for our slope, we're going to do y2 minus y1 and x2 minus x1. So that's negative 12 minus negative 12. And notice it is a double negative. I have to write that or switch it into a positive if you see that. But we can't just make it negative 12 minus 12. And then on the bottom, again, we follow that same pattern. So we have negative 5 and we're subtracting negative 6. So negative 5 minus negative 6. When we have a double negative, remember that turns into a plus. So on top, we really have negative 12 plus 12. On bottom, we have negative 5 plus 6. So notice I'm separating the top and the bottom still. I'm simplifying those separately. So on top, negative 12 plus 12 is 0. On bottom, negative 5 plus 6 is 1. And 0 divided by 1 is just 0. So our slope of this one is 0. So now let's talk about what the y-intercept of a line is. So when we are looking at a line that's already graphed, to figure out the y-intercept, you're going to look at the point where it crosses the y-axis. So this point right here is your y-intercept. And since the x-coordinate of any point on the y-axis is always going to be 0, 0 comma y will be your ordered pair for any y-intercept. So any y-intercept will always have an x value of 0 because no matter what point I pick on this y-axis, if I were to write the ordered pair, the x-coordinate is 0 and then the y-coordinate is whatever number it's sitting at on the y-axis. So just keep that in mind. 0 comma y is always the format for any y-intercept. And we will often use b, so you might see 0 comma b as well. That is what we use from y equals mx plus b to represent that y-intercept. So in this case, this point right here, in our example here, erase my other points. So that one right there, that y-intercept of this line is at 0, negative 1 for my ordered pair. So now looking back at the same graphs that we already found the slope of previously, let's talk really quickly about our y-intercept for each of those graphs. So we already talked about the steepness of the line. Remember that when we talked about slope, when it was a positive slope, it went up from left to right. When it was a negative slope, it went down from left to right. A slope of 0 was a horizontal line and an undefined slope was up and down. Now we're not going to worry about the slope. Now we're going to talk about the y-intercept. So we're going to look for the point that crosses the y-axis. So if you think about the y-axis as this vertical axis right here, you want to find the point where that blue line, in this case, crosses that y-axis. So in this case, that is this point right here, which is the origin in this case, which is 0, 0. Now on number 6, again, we want to look, if you highlight the y-axis, we want to look for the point where our blue line crosses the y-axis, which would be this point right here. So if we start at our origin, we go left or right, nothing. We don't move left or right. We just go straight from that origin right here. We go straight down 1, which means that our ordered pair for this one is going to be 0 comma negative 1, just like the example that we had on the last page, but just a different line. So it's possible for different lines to have the same y-intercept. I might draw in a linear graph right here that goes through that same point. So keep that in mind. The y-intercept is not specific to only one possible graph. All right, and then number 7 here, we see the point where the graph crosses the y-axis is this one here. If this was our origin, we go down 1, 2, 3. So that's at -3. Remember, it's always written 0, comma, and then whatever that number is. So 0, comma, -3 is our ordered pair there. Now, this one is a special case. So if you look at your y-axis, this blue line does not and will never cross that y-axis. So there is actually no y-intercept on this graph. So that is possible for it to have no y-intercept. So just as a quick reminder, slope, remember slope is telling us how steep the line is. So we'll talk more in the future about what makes it steeper, what makes it less steep. And then one thing I did want to point out, positive slopes, remember, go up from left to right. Negative slopes go down from left to right. If we have a horizontal line, it is a slope of 0. And if we have a vertical line, it is an undefined slope. Y-intercept, remember that the y-intercept is the point that crosses the y-axis on your line. So if this is my line and this is the point that crosses the y-axis, we'll say at -2, then my y-intercept would be at 0, comma, -2. And remember, it is always 0, comma, y or 0, comma, b for that y-intercept.